Yo, what y'all doing, bro? Day by day, I think my fucking motivation is getting down. Tomorrow is test. I will not study a drop of any knowledge of that shit. And let's get started with this, and let's end it with this. I think I will coding timer. That this is a useful concept because this fucking never goes zero. Like, it will fucking slow down anytime I do this. React can change how you think about design. You look at the app you build. When you build a user interface in React, you will first break it apart into pieces called a component, and then you will describe the different visual state for each of your component. Finally, you will connect your components together so that the data flows through them. In this tutorial, we will guide you through the thought process of building a searchable product data table with React. Okay, got you. Starting with the mockup. Imagine that you already have a JSON API and a mockup for a designer. The JSON API returns some data that looks like this. Okay, got you. Category, price, stocked, and name. Mockup look like this. Okay, got you. To implement a UI in React, you will usually follow the same 5 step and break the UI into a component hierarchy. So start by drawing boxes around every component and subcomponent in the mockup and name them. If you work with a designer, they may have already named this component in their design tool. Ask them. Depending on your background, you can think about splitting up a design into components in different way. Program. Use the same technique for deciding if you should create a new function or object. One such technique is the separation of concern, that is, a component should ideally only be concerned with one thing. Okay, components should ideally be considered with one thing. If it ends up growing, it should be decomposed into smaller subcomponent. CSS, consider that you would make class selector for however component are a bit less granular. Design, consider how you would organize the design layer. If your JSON is well structured, you will often find that it naturally maps to the component structure of your UI. This is because UI and data models often have the same information architecture. Okay, same. Okay, this is the same shape. Separate your UI. Okay, would each component match one piece of a data model? There are 5 components on the screen. Okay, one is the search bar with only so product in stock. That's good. Filter product, filterable product is the default, I think. And purple is the table in which everything does one stuff. And these two product category row. Okay, got you. And these all are product rows. Okay, if you look at the product table, lavender. What the fuck is lavender? Okay, okay, lavender. Oh, you will see the table header content in the name, and price level is an its own component. This is a matter of preference, and you can go either way. For this example, it is a part of product table because it appears inside the product table list. However, if this header grows to be complex, you can move it into its own product table header component. Okay, this is identification component in the mockup. Arrange them into a hierarchy. Component that appear within another component in the mockup should appear as a child in this hierarchy. Okay, filter by product, search by product table with rows, product rows. Build a static version in React. Now that you have your component hierarchy, it's time to implement your app. The straightforward approach is to build a version that renders the UI from your data model without adding any interactivity. Yet, it's often easier to build the static version first and then add interactivity later. Building a static version requires a lot of typing and no thinking, but adding interactivity requires a lot of thinking and not a lot of typing. Got you. To build a static version of it that renders your data model, you will want to build component that reuse other component and pass data using props. Props are a way of passing data from parent to child. Okay, got you. Properties, props. Got you, bruh. And with the concept of state, don't use state at all to build this static version. Static is resolve state is resolved only for interactivity, that is data. Like I got you. Does nothing, bruh, does nothing. Categories. Okay, got you. First is to make static. Okay, got you. Static page. Step 3, find the minimal. First, laying out the fucking component in a hierarchy, and second is to make a static page, and then UI state to make you act, and the you let user change your underlying data model. You will use state for this. Think of state as the minimal state of changing data that your app need to remember. The more important principle of structuring state is to keep it dry. Don't repeat yourself. Figure out the absolute minimal representation of the state your application needs. The compute everything else on demand. For example, if you are building a shopping list, you can store the item as an array in state. If you want to also display the number of lists in the item in the list, don't store the number of item as another state value. Instead, read the length of your array. Now think of all of this pieces of data in this uh, example application. The original list of product search text has entered. Does anything change? Okay. Deep type prop was a state argument you pass to the function. The component memory. Okay. Identify what's state you live in. Identify. Hmm. Check prop to form field with an on chain handler. The editing the form doesn't work yet. The console log in the sandbox will explain why. You provide a value prop to a form field without on-chain handler. This render or read only field in the sandbox above product table and search bar. Read the filter table and install prop to render the table, the input, and the checkbox. For example, here is how search bar populates the input data. You haven't had any code to respond to the user action like typing yet. This will be a final step. Add revertible data flow. Currently render correctly with props, but change the state. You will need to support data flow the other way. The component deep deep in hierarchy, need to update the state in filterable product table. You React makes the that data flow explicit, but it requires a little more typing than two-way data binding. If you try to type or check the box in the example above, you will see the React ignore your input. This is international by writing input value filter text. You will set the okay state false. However, filter on filter text change filter text set filter text. I don't get it. Why? I take on filter change text. The change. Okay. Installation. Okay, has been designed for the start for granular adoption. You can use as little or as much as React as you need. Whether you want to get a test of React, add some interactivity to a HTML page, or start a complex React Power app, this section will help you get started. Try React and try. You don't need installation anything to play React. Try to enter this sandbox. You can edit it directly or open it in a tab by pressing the fork button in the upper right corner. Most pages in the React documentation contain sandbox like that. Outside other React documentation, you will find hmm, where I can write only, bro. That is a bummer. Create a React app. Build a React from scratch. If a thing is not good for your project, you build your own framework. You want to learn basics of React. You can build a React from scratch. Add React to an existing project. If you want to try using React in your existing app or website, you can add React to an existing project. Hasn't it? If you want to build a React, we recommend starting with a framework. If your app has constraint and not well served by existing framework, you prefer to build your own framework, or you just want to learn the basic of React, you can build a from scratch full stack framework. These recommended frameworks support all the features you need to deploy and scale your app in the production that will have interchanged the latest um, okay, gotcha. These apps can be deployed to a CDN or static hosting service without a server. Additionally, these frameworks allow you to add server-side rendering on per root basis when it makes sense for you. Use case Next.js, AppRouter Next.js. AppRouter is a React framework that takes full advantage of React architecture to enable full stack React apps. And Next is maintained by Vercel. You can deploy a Next.js app to any hosting provider that supports Node.js or Docker containers, or to your own server. Next.js also supports static export, which doesn't require a server. React Router v7 framework. React Router is the most popular routing library for React and can be paired with Vite to create a full stack React framework in infantsize standard web APIs and has several ready to deploy templates for various JavaScript runtimes and performs to create a new React router framework project run. Um, React router is maintained by Shopify. Okay, Shopify. Okay, Expo for native apps is a React framework that lets you create universal Android, iOS, and web app with true native UIs. It provides a SDK for what the fuck is SDK? Software development kit. Software development kit that makes the native part easier to use. You to create a new Expo project you run. Okay, if you want to know other way, pay other framework. Okay. Is there anything like fucking React and Next.js combined tutorial? Hmm.
Here's
Okay.
how I would learn React if I was to start over again in 2022. First of all, before learning React, you should not be skipping on learning HTML, CSS, and JavaScript. Just like you should not be skipping on foreplay. It will make the ride
Damn, what the
much
fuck?
a couple things with vanilla JavaScript. You should be ready to learn React. Now first then head over to beta.react.js.org. This is the site for the official React beta doc, which in my opinion is the best resource to learn React nowadays. I would read and follow the examples through in this
That's the thing.
documentation up to this point here. Everything else after that is just a little bit more advanced, so I would not recommend diving into those just yet. After that, you should have a pretty solid understanding of React. I would go to this video here by Brad to work through an example of how to build an app with React. After that, start building projects. Anything you would like. For me, I built a Spotify clone to so here's how I would learn React if I was
Okay,
to
that's nice.
नो डियर रिएक्ट
हाय एवरीवन, ये वीडियो सबके लिए है जो मुझसे रिएक्ट
Should I build my web application using React.js or Next.js? It's an odd question that I've been getting asked a lot lately. It's odd because Next.js is actually built on top of React.js. At a technical level, React is just a view library and Next.js is a full-on framework. I think the question really is, should I be writing in Create React App or Next.js? While Create React App is great for building single-page applications, Next.js is the choice of web professionals who want to build applications because of its built-in routing, server-side rendering, and static site generation. So if you're thinking about which one to learn to give you the best shot at getting a React job, learn Next.js. Should I build my
The fuck is his face? Fuck off, bro. Sorry about that. Okay, YouTube React comp. Oh, I think she's from like Dr. House. Okay, React.js full course playlist or something. I watched this shit, but I don't want to rewatch it though. Okay, I had to eat, so my mom called. Oh, this is the one I want to learn, cause like it's like kind of short, kind of. Okay, I think this is kind of advanced. Oh, let me copy Grok. I just want to use Grok instead of ChatGPT for sometimes. Look at this. What did I tell you, brothers? This ain't moving a bit. Bro, I was signed in, bro. This fucking bitch Google literally like. Okay, new types cover basis of TypeScript ending with grep state progress from beginner introduction intermediate advanced TypeScript. It appears to be a constant series of like likely from code evolution, coevolution, modern hooks, basic. Okay, beginner level 441. Okay, and also apply coverage beginner to advanced. Yeah, 18 feature like hook and concurrent throughout the hook. How long is the video all together, and how much time will it okay, got you. Summarizing all video length required per passing is duration for the playlist. Let's go from her world. Assuming you're without pausing, it will take amount of you can fit in around 10 hours at factor 15 hours. How long this is, bruh? Okay. Um, ChatGPT. Nah, Grok, bruh, Grok. Fucking hell. I have no fucking. I can't wait for a month, like 2 weeks. Like realistic, like if I have to use state, but will watch all of the video shape not react like views the programming in React and spread it out for 3 weeks. How long her uh, and the BGI part will take me lesser time to even understand, so spread the video in order hmm, in order of 3 weeks to finish this stuff. Then how long, how many video should I learn per day? Okay, realistic. This is what we want to learn, bruh. I want to ask this shit about AI and stuff. Okay, this shit is taking longer than usual, brother. So, Elon Musk, do something, bruh. Okay, this is nice. This UI is kinda slick. Who the fuck make this? It's only for title with. And let me take a fucking puff. Let me see what the timer says. 46 minutes. Nice up. Okay, I excluded videos. week 1 to 48, intermediate hooks and rendering 49 to 60, 93, moderate pace as um I need to save this shit, brother. Copy. Where should I fucking save this? Strict plan. Okay, bruh. This is a fucking strict plan, bruh. Where's my fucking... Okay. No, 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 not a new folder. Not this. What is the shortcut for making new file? New text document. For 21 days straight. BEGIN to advance by Grok. Okay, so this is the fucking... let me increase the font. Title, okay, too big, I think. I need to paste the link of the playlist, by the way. Just make it...
Begin by setting up our development environment.
Bro, he's fucking Indian. I got a kink for like bad kink. What the fuck? Like turn off from Indian fucking accent, bruh. I'm I'm not racist or something, but I'm kind of racist, but this is kind of fucked up, kind of shit, bruh. Every time I hear a Indian teasing programming, bruh, I just want to shut the fuck up, bruh. This shit will be here, right below this fucking camera. Okay, let me fucking put my light and I want so fish camp. Video capture. Okay. Okay, fucking hell. What's up, dudes? And this is me. This is me, bruh. Leave this shit. This is me, and this is my commitment. Yeah, sorry. God bless. Okay, this is my commitment for 21 days. Today is... what is the today's goal? Okay, I'm gonna like... what the fuck is that? Fucking hell. What I want to do is... not even smaller than this, I think. Okay, this is good. And then today is the commitment that I need to fulfill is 1 to 7. Okay, introduction to components and hooks update. Okay, gotcha, bro. 7 videos, I think. Does 7 be included? I think so. So like 7 included. Okay, got that's it. And then okay, got you, bro. So I need to like fucking do this up to 7. Okay, let me like I got RAM for this shit. Fucking hell. Okay, where the fuck is that? Okay, got you.
Begin by setting up our development environment. For React,
No,
we
just
need two things installed:
delete.
Node and a text editor of your choice. For Node, and install it and
Okay, got you.
open VS Code inside that folder. This folder is going to be our workspace for the rest of the series.
Okay, what I
Now, to create a new React application, we will be making use of Create React App. Create React App is a command line interface tool that allows you to quickly create and run React applications with no configuration. What that means is you simply run a command and an entire React project is created for you. So back in VS Code, open the integrated terminal and run the command npx create React app followed by the name of the project.
control back.
Let's call it Hello World.
npx.
Once the command completes, you should have a new folder called Hello World.
React.
To run this application,
React dash.
once the command completes, you should have a new folder called Hello World.
Hello world.
To run this application, first navigate inside the project folder. cd
Nigga, what the fuck happened? Okay, it's like,
Hello World. Now run
bro, I'm getting fucking.
the cd applications. You should followed by the name of the project. Let's call it Hello World. Create React app use of create folder React and put inside that folder. This folder is going to be our workspace for the rest of the series.
Bro, I like it.
Now, to create a new React application, we will be making use of Create React App. Create React App is a command line interface tool that allows you to quickly create and run React applications with no configuration. What that means is you simply run a command and an entire React project is created for you. So back in VS Code, open the integrated terminal and run the command
Okay, got
npx
npx
create React app followed by the name of the project. Let's call it Hello World.
Just JSON, brother.
Once the command completes, you should have a new folder called Hello World. To run this application, first navigate
Wait the
inside
fuck up,
the project folder.
What the fuck is happy hacking, bro? You ain't fucking hacking from React, I think. From the understanding of it. Okay. It's only 40 minutes. Okay. I need to move my fucking phone out of my sight. Oh, by the way, I need to check what my exam is. Which exam is? Wait the fuck up. Wait the fuck up. I ain't doing no exploring. पहिलो सेमेस्टर बिएससी सिएस आइटी विद्यार्थीलाई यो जानकारी गराउँछु कि 8 फागुनमा क्याम्पसले स्थानीय बिदा राखेको कारण उत्कृष्ट दिन हुने भएको म्याथको इक्जाम फागुनको 11 गते 2081 मा हुनेछ. Okay, got you, bro. It's like say postponing. My exam was supposed to be yesterday, but it was postponed to like 3 days later. But tomorrow is physics, and I gotta know shit. I'm gonna get fucked in the ass. Fuck that shit, bro. Okay. Why is this fucking taking so long, bro? My fucking shit ain't that slow, bro. What I want to do is like stream, cause like I've been taking break a lot in between. So like, welcome to now building well camp. Okay, what's up? Oh, okay, switch this shit off. Okay, but okay, details, webcam, stream. Connect here. No, save this shit. Okay, this is such a drag. Okay, what the fuck am I supposed to do? Create new. What is the fucking date of this? Tomorrow. Today I will be uploading, but tomorrow I want to like do a fucking stream. Got that, bro? Did my fucking finish? Hell no.
Folder. CD hello world.
I understand that part.
Now run the command
My shit is
npm
lagging, bro.
start.
My shit is so hot.
The command will open the browser on localhost port 3000 with your Hello World application up and running. Localhost start.
The fuck? My shit is so hard, bro. Cross this shit. Bro, what the fuck is going on, bro? Am I downloading a virus? How big is this, bro? React DOM? CRA template? What the fuck is that? Why is my shit so hot? Okay. Oh, I will not write. Okay, initialize a grid repository. Okay, shit has been downloaded. God dang fucking hell. So like npm start. That's a fucking okay. I just cd on that bitch. And then by grok. Don't save. I didn't do shit in that. So why? Installing template dependency using npm. How much? How much do I have to learn? So let's fucking go to GitHub. Like people humble me like left, right, and center, bruh. Blood. Everyone been typing all of this shit, bruh. I've been humbled non-stop. This is a fucking guy who is like, what the fuck? Why is this only him? Dashboard, real one, okay. Bruh, more, bruh, what the fuck? Front end mentor. Okay, where is the pull request, tasks, arcs, anything? Projects? Not mine, bruh. Code spaces, blank GitHub. Use this. What is use template mean? Setting up your code space. Is this like an online code editor? Jupyter is latest web-based interactive development for notebook code and data. .NET full stack web application template written in C#. Okay. No online code editor. Yeah. Fuck that bitch. Fuck that joint, bro. Clear. Happy hacking, bro. What the fuck? CD. Fucking dot slash in this. Hello dash world. CD master. What the fuck? This is so fucking. What do you call it? Zesty. npm start. Okay, what is this? Is this starting development server? Okay, it fucking open on its own. Is this supposed to load something? Cause it like in the loading screen stuff. Okay, let's see.
The command will open the browser on localhost port 3000 with your Hello World application up.
By the way, he doesn't sound Indian right now, so I'm already starting to like it, bruh. Fuck Indians.
And running.
Sorry about that. Fuck that shit.
And you can see the
am I so fucking mad
instruction to get started. Edit app.
It's just a joke. Benchot. It's just a joke.
.js in the source folder. So let's go back to VS Code, expand the Hello World project, expand the source folder, and edit app.js. I will change the text to hello.js source folder and edit app.js.
Okay. There is no HTML.
I will change the text to hello world. And let me save the file.
Okay, by the way, if I'm learning like 21 days straight of this shit, I wanna do like deep in this shit, bruh. So like node/module is all the packages in this shit which needed to be installed. So like React DOM and shit is all saved in here. Public is like fucking like what do you call that shit, where everything can be renders type shit. And then source is all, what the fuck is this? This is a nice looking fucking. Okay, I don't know shit about this. The tester.js is like, I wanna see return div app name class logo edit. Okay, I wanna do this right. So like, okay, paragraph slash code. Okay, this is fucking okay, return app is this, I think. Header, app header, image. Okay. Hello world. It is my fucking IP. It better not be, but I don't know what people will do. Okay, it changed it. Hello. I type hello as hello, bruh.
When the changes are saved, the browser will automatically refresh and you should see Hello World displayed in the browser. So there you go, your first React application up.
I'm pausing this shit a lot because like I want to launch it, right? Hmm. Hmm. Done. Since the day was
and running. Before we move on to the next video though, I want to discuss an alternate approach for creating React applications using the Create React App package.
okay.
The first method, which we already had a look at, is using npx. We run the command npx create react app followed by the project
This is
name.
what we did.
But what exactly is npx?
NPX. What the fuck is that?
npx is an npm package runner which gets installed when you install Node. And that is how we are directly able to run Create React App without having to install it. npx takes care of that for us. Now there is a slightly different approach which just depends on npm. In this approach, we install the Create React App package globally and then use the package to generate the projects.
Okay.
So the first step here is to install the package globally using the command npm install create react app -g.
What the fuck is
Once
G?
it is installed, you can run the command create react app followed by the project name. I prefer the first approach because I don't have to install the package globally and I don't have to worry about constantly updating the Create React App package. I will be using
Why is that?
npx, but I wanted to show you the npm approach as well because you will find other videos and articles which take that approach. The last thing I want is for a beginner to be confused with the very first step of creating a React application. Now that we understand how to generate a simple React app, in the next video, let's In the last video, we saw how simple it is to create and run a basic React application using Create React App. Now, at the same time, it is also really important to understand the files and folders involved and how the control flows when you run the application. Let's take a look at that in this video.
Git ignore. I know that shit.
I have
Package
opened the Hello
JSON, I
World
know
project
that shit.
in VS Code, and
Me
you can see
nothing.
that at the root
And
level,
tag is
we have
all
3 folders and 4 files to begin with.
which I'm comfortable.
Let's start with
because don't need to do
package.json.
anything in that right now.
This file contains the dependencies and the scripts required for the project. You can see that we are using React version 16.5 and that is listed as a dependency. We also have a few scripts to run the application, build the application, or even run tests. Now based on whether you have just npm or yarn as a package manager, you're going to see yarn log or package log files. They simply ensure consistent installation of your dependencies and you don't really have to worry about them. We also have a git ignore and a readme file. Next, let's talk about the folders. The first one is node modules, and this is the folder in which all the dependencies are installed. It is generated when you run the create react app command or when you run npm install. The next folder is the public folder. This folder contains 3 files. Out of the 3, manifest.json is concerned with progressive web apps, which is out of scope for our discussion. We have the fave icon, which you see in the browser tab, and this is nothing React specific. So as a beginner, you only have to concentrate on the index.html file. The index.html is the only HTML file you're going to have in your application. We are building single page applications and this is it. The view might dynamically change in the browser, but it is this HTML file that gets served up.
Gotcha.
Typically, you're not going to add any code in this file. Maybe some changes in the head tag, but definitely not in the body tag. You want React to control the UI. And for that purpose, we have one div tag with ID is equal to root. At runtime, the React application takes over this div tag and is ultimately responsible for the UI. Please make a note of this div tag and we will come back to it shortly. The next folder we have is the source folder, which is the folder you will be working with the most during development. The starting point for our React application is index.js. In index.js, we specify the root component, which is app component, and the DOM element, which will be controlled by React. The DOM element in our example is an element with an ID of root. And if you can recollect, this is the element in our index.html file. We call this div element as the root DOM node because everything inside it will be controlled by React.
Okay, got you.
For the Hello World application, the app component is rendered inside the root DOM node. That brings us to the app component, which is present in app.js. This is also the file we edited in the last video and is responsible for the HTML displayed in the browser. In other words, the app component represents the view which we see in the browser. With app.js, Create React App also generates a CSS file for styling and a test.js file for unit tests. The CSS file contains classes which are applied in the app component, and the test file contains a simple test case. We also have an index.css file which applies styles to the body tag and the logo SVG, which is referenced in the app component. Finally, we have service worker, which is again concerned with progressive web apps and can be ignored as a beginner.
Okay.
So that is the folder structure of a React application created using Create React App.
When was it?
When you run the command npm start, index.html file is served in the browser. Index.html contains the root DOM node. Next, the control enters index.js. React DOM renders the app component onto the root DOM node. The app React DOM renders the app component onto the root DOM node. The app component contains the HTML, which is ultimately displayed in the browser.
Got you.
Now then, I have mentioned the word component several times already. But what exactly is a component? In the very first introductory video, we had a brief overview of React's component-based architecture. In this video, let's get into the details of it. In React, a component represents a part of the user interface. Going back to the example from the earlier video, you can say that our application has 5 components. One for header, one for side nav, one for the main content, one for the footer, and finally, one component to contain every other component. The containing component is the root component and is usually named as app component in your application. Each of the 4 nested components describe only a part of the user interface. However, all the components come together to make up the entire application. Components are also reusable. The same component can be used with different properties to display different information. For example, the side nav component can be the left side nav as well as the right side nav. And as already mentioned, components can also contain other components. For example, app component contains the other components. App component contains the other components.
Header, okay.
Now, how does a component translate to code in our application? A component code is usually placed in a JavaScript file. For example, a component is placed in app.js. You can also have component files with .jsx extension, but for this series, we stick to the simple .js extension. We will, however, take a closer look at JSX in one of the upcoming videos. Alright, so a component is basically the code inside a .js file. But what does that code look like? That depends on the type of the component. In React, we have two component types,
Okay, component
a
type.
stateless functional component and a stateful class component.
Class component.
Functional components are literally JavaScript functions. They return HTML, which describes the UI.
Okay,
For example, a function called welcome, which returns an h1 tag that says hello Vishwas. Now I know the HTML doesn't say that, but for simplicity, just assume we are returning regular HTML.
Okay, gotcha.
Class components, on the other hand, are regular ES6 classes that extend the component class from the React library. They must contain a render method, which in turn returns HTML. For example, class welcome extends React.component, and the class contains a render method, which returns an h1 tag that says hello Vishwas. Now what is the difference and when to use one over the other?
Bro, he's an Indian.
We will discuss in the next few videos. But make a note of the two component types, stateless functional components and stateful class component.
Stateless, straightforward.
Now that we have some understanding of React components, let's examine the app component in our Hello World application. If I go back to VS Code, the first thing to notice is the file extension, .js. So it is a JavaScript file. If you take a look at the code, you can clearly see that this is a class component and not a functional component. The class is named as app and extends the component class from the React library. It contains a render method, which in turn returns some HTML. Now this is a simple Hello World application, and hence we have just one component. You can have tens, hundreds, or even thousands of components. Facebook, I believe, has over 30,000 components. More complex the application, more the number of components. Alright, then let me quickly summarize what we've learned about components. Components describe a part of the user interface. They are reusable and can be nested inside other components. There are two types of components, stateless functional components and stateful class components. Components are the building blocks of any React application, so it is crucial to get a good understanding of the two types of components. Let's start with functional components in the next video.
Class component, okay.
In this video, let's take a closer look at functional components. Functional components are just JavaScript functions. They can optionally receive an object of properties, which is referred to as props, and return HTML, which describes the UI. Now the HTML is actually something known as JSX, but for the sake of understanding from a beginner's point of view, let's just call it HTML. So a functional component is a JavaScript function that accepts an input of properties and returns HTML that describes the UI. Let's go back to VS Code and create our very first functional component. To keep things simple, in the app component, I am going to remove all the HTML except the outer div tag. And now let's create our component. And the component is simply going to output a message, hello Vishwas. A component is nothing but a JavaScript file. Let's start with that. First, I'm going to create a new folder called components. And within the folder, I am going to create a new file called greet.js.
Okay, component.
For component file naming convention, we will use Pascal case.
Okay, Pascal.
Now within the file, Pascal case.
Some probably gurus or programming be like, what is this little bit so happy about, bruh? I'm just happy about starting, bruh. Such an old ass up, bruh.
Now within the file, the first step is to import React. So import React from React.
Okay.
Any component you create, always make sure to import it.
Okay.
Next, let's create a new function.
From React.
Function greet and return
What is
an
this?
h1 tag
Okay.
that says hello Vishwas.
Function.
And that is pretty much it. You have created your first functional component.
Okay, function.
But as it stands now, the HTML hello Vishwas is not going to be rendered in the browser. The greet component is in no way connected with the rest of our application. So what we have to do is export the greet function from greet.js, import it in app.js, and then include it in the app component. So in greet.js, export default greet. In app.js, import greet from components folder greet.js file. And we can omit the .js extension. Next, to include greet component in app component, we simply specify the component as a custom HTML tag. And if there is no content between the tags, you can simply change it into a self-closing tag.
Did you just delete all of this shit?
App.js default greet. In app.js, import greet from components folder greet.js file. And we can omit the .js extension. Next, to include greet component in app component, we simply specify the component as a custom HTML tag.
Okay.
And if there is no content between the tags, you can simply change it into a self-closing tag. Now, if we save both the files and take a look at the browser, you should be able to see Hello Vishwas. Your first functional component is up and running.
What the fuck?
Now, although
Why am I getting this? Check the render method of app. Create bundle element is invalid. Expected a string or class. The fuck? Change line. Added line. Receive an object. Yes, this is what I did, what you already wrote. Correct from grade. This doesn't work, bro. What the fuck is done? Greet, return. This should be one liner or something. Just for style, let's do this. Okay, the fuck? It was the fucking. Then what was it, bro? What did that even change? What even changed? Nothing. What?
Though our functional component works perfectly fine, the convention or preference, I would say, is to use arrow functions to define them.
Okay.
So let's rewrite the greet function with the ES6 arrow function syntax.
Got you.
Const greet is equal to empty parentheses, the fat arrow syntax, and then the h1 tag that says hello Vishwas. The syntax looks more concise than the previous approach.
Question mark?
Syntax-wise, it also has additional advantages which we will discover as we proceed with the course. If you are new to arrow functions, please get a basic understanding of how they work, as we will be using them a lot throughout the series. Alright, before we proceed to the next video, I quickly want to highlight one thing about exporting and importing components. Please note here that we are exporting greet component as a default export from greet.js. This is what allows us to import the component with any name. I can change greet to my component
Got you, bro.
and change the tag to my component, and you can see that it still works as expected.
Yeah.
But in certain articles or videos, you might also find named exports. Let me comment the default export and prepend the constant with the export keyword. This is what is termed as a named export. In this situation, you have to import the component with the exact same name. If I save the file, you can straight away see that we have an error. Does not contain a default. So you have to change the import statement to import the greet constant, import statement to import the greet function. So import within curly braces the greet constant, and then use that as the custom HTML tag. If I save this and go back to the browser, you should be able to see Hello Vishwas. Now for most of the cases, we will be using default exports, but I just wanted to bring named exports to your attention so that it can be of some help in the future. Let me revert back to default exports, and in the next video, let's take a look at class components in React.
Okay, too easy, brother.
In this video, let's take a look at class components in React. Class components are basically ES6 classes. Similar to a functional component, a class component also can optionally receive props as input and return HTML. Apart from the props as input and return, component also can optionally receive props as input and return HTML. Apart from the props, a class component can also maintain a private internal state. In simpler words, it can maintain some information which is private to that component and use that information to describe the user interface. To get a comparison, let's create the exact same greet component, but this time as a class component. Let me create a file called welcome.js. I am simply changing the name because we cannot have two files with the same name. Now, whenever you create a class component, we need to include two imports. We need React and the component class from React. Next, we define the class. Let's call this class welcome. For this class to become a React component, there are two simple steps. The first step is it should extend the component class from React. So class welcome
Class component, what the fuck is
extends component. Second step, the class has to implement a render method which will return null or some HTML. Render method which returns some HTML. And that is pretty much it. You have created your own class component. Again, right now, this component is in no way connected with the rest of our application. So what we have to do is export the welcome class from welcome.js import it in app.js, and then include it in the app component. So export default welcome, and back in app.js, we are going to import welcome from components/welcome. And within the HTML, I'm going to add the custom tag, welcome. If we save all the files and take a look at the browser, you should be able to see the text class component. So the basic class component is working. Now that we have seen how to create a functional component and a class component, you might be wondering what is the advantage of using one over the other and when exactly should working. Now that we have seen how to create a functional component and a class component, you might be wondering what is the advantage of using one over the other and when exactly should you use a particular component type. Now, I definitely want to discuss
Can't I use like this name input? Fucking hell. Copy, paste, and welcome. Bro, I didn't do anything in that. Okay. If we do that, then we need this. Save that shit. Import as grid was not found possible or post default. Okay, what the fuck? Compilation, okay. Hey, looked inside grid and only found full export, and now you're trying to import called grid. You're mixing up what it means, like, okay. Notice means default, but in app.js probably did this. Though I want a named. Bruh, you were wrong again. Save that shit. The problem is welcome, man. Mm, for default welcome, save that shit, and then remove this joint. But such a bitch ass up. Fucking hell, what am I doing?
That, but what you have to keep in mind is you might only partially understand the discussion. And that is completely fine at this point. We will be listing down topics we haven't covered yet, so it will definitely be tougher for you to relate to. And that is why I am going to briefly talk about them just so that you have a basic idea. As the videos progress and you learn more about the different concepts in React, it will start to make much more sense to you. So let's compare the two component types. And let's begin with functional components. Functional components are simple functions receiving props and returning a declaration. You should try to use functional components as much as possible. And by that, I mean if it is possible to create a component with both the approaches, always go with the functional component approach.
Okay.
The first advantage of using a functional component over a class component is the absence of this keyword, which you will encounter in a class-based component. This keyword can be quite tricky for a beginner, and functional component will help you in that aspect. The second advantage is you will be forced to think of a solution without having to use state. If you have a number of components, each with their own private state, maintenance and debugging your application is kind of difficult. Functional components tend to be without any complicated logic and are mainly responsible for the user interface. This is why functional components are also called stateless components, dumb components, or presentational components. Class components, on the other hand, are a bit more feature-rich. They can maintain their own private data, also called as state. They can contain complicated UI logic, and most importantly, they provide lifecycle hooks. We will discuss about lifecycle hooks in detail later on in the series, but for now, I just want you to know that they are really useful. And because of what they are capable of and how they are used, class components are also called as stateful components, smart components, or container components. Alright, now so far, we have seen three components: app.js, greet.js, and welcome.js. In all three components, we simply return some HTML. But let me tell you, that is not regular HTML. It is something known as JSX. But what exactly is JSX? Let's take a look at that in the next video. Thank you guys for watching. Don't forget to subscribe and enable notifications. I'll see you guys in the next video. Alright guys, before we move on to JSX, I have a quick update on a new feature which was released as part of version 16.7 alpha. And I had to create this video because the new update has this cool new feature which kind of contradicts what we've learned about functional versus state components. I had already recorded the previous content, so what I can do now is update you guys as well on this new feature and clarify some of the queries you might have if you're getting started with React sometime in the future. In the last video, we had a comparison between the component types. I mentioned that class components have the benefit of using what is known as state and also the lifecycle hooks. And I also referenced functional components as stateless components. Unfortunately, I will have to take that back. At the 2018 React conference, the React team introduced a new feature proposal called hooks. And as you can see in the official documentation, hooks are a new feature proposal that lets you use state and other React features without writing a class. They are currently in React version 16.7.0 alpha and being discussed in an open RFC. So state and code similar to lifecycle hooks, which were exclusive to class components, can now be used in functional components as well. With that in mind, let me talk about 2 points that will answer any questions you have now or no breaking changes. Even though hooks are in new feature proposal right now, they will not break any code in your application even with the stable release. They are completely opt-in and also 100% backwards compatible. If you don't want to, you don't really have to learn or use hooks in your application. We are going to take a look. And this is also the reason whatever we have learned so far in this series still holds good. Except for the fact about functional components being stateless and the disadvantage of not being able to use lifecycle hooks. As a correction to that, from now on, we will simply call the component types as functional components and class components. The second point is about the content on hooks in this series. Personally, from a beginner's point of view, I feel you really should understand using state in class components, using lifecycle methods in class components, and also experience the frustration with the this keyword when working with class components. Only after you go through this journey will you truly be able to appreciate what hooks bring to the table. And also, at this point in time, they're still in alpha, and I don't want to create content right away. So if you're watching the series now, or even a few weeks or months from now, know that I will be creating content on hooks, but it will be after understanding state, event binding, and lifecycle hooks in class components. So don't worry about React updates affecting the series. You're learning the latest content, and I will make sure to always let you know of new features and changes. Alright, with this overview on hooks, let's get back on track with JSX in the next video.
Okay, that's for now. So pause this set. And what I want to do is take a little break and then watch 1-2 episode of Big Bang Theory and then continue with Node, not React. Okay, you got that? So it's 7:01. So Node, I will be planning in my head what projects should I build. So tada, bye bye. Wait, guys. There's a fucking big things I'm gonna do, like ever since I started learning like web development, I was kind of scared about AI type stuff, and um and like no why even in the first place I was learning Node Express was to like get internship in startup companies, cause like my senior brothers who I'm close with, or the team bros who is kind of older than me, suggested me to learn Node Express, which is kind of popular in startup in Nepal especially. So I can get easy I can easily get internship in that field if I learn that, and I'm still learning it, and I decided on to make a fucking project. What project, you might ask? Is a task manager, which is my next project, is like which has authentication, authorization, hierarchy of like boss and what do you call that? What do you call peasants? Boss and then workers or something. I don't know. I will think about that, and then think about that. Like task manager, I can assign tasks for that and deadline stuff and stuff, which I'm gonna make with Node Express, Mongo. React is what you know that I'm learning React Like if you are watching this, then go to like um 30 minute or something. I don't know. This is my, what do you call that, timeline or time step I'm gonna learn in. So in 3 weeks or even a month, I'm gonna learn React. Make While I'm catching up with React while learning this for 21 days, I'm gonna be building step by step to get get to my goal, to make the task based manager. So fuck about that. Where was I? I was kind of scared about this AI era. So even before I was, I wanted to learn Node. I wanted to learn Go. This is not a really smart idea for a lot of you, but this is what makes sense and what I believe in. This is like expanding, like Go depth and something, but this is like my I really want to migrate from JavaScript basically to other stuff while still knowing I'm building a Node Express. So I've taken a challenge for myself to learn Go. It sounds fucked up. Like I want to learn React, build in Node within this month while still learning Go, bit by bit, for like maybe it might take 6 months, 3 months, if or even faster one, but still this is my migrating language. The I know this is dumb. I should focus on one, but but um but this really makes sense in my mind, which I can't really talk about it. Like my first language isn't English, by the way, so like anything goes. So let's not go, bruh. So I've been doing kind of research and stuff. It was like 7. It's like 11. Not the most of the time, but I really want to learn Node, like ARCs, AI stuff, and stuff like that. So what I'm gonna do, like I'm doing really like messed up stuff, cause my college is still in between. So I got like a year and a half before I got real time. Like my schedule is like 11 a.m. to 7:40 p.m. college, and then there is no time for internship and stuff. So what my goal is at the um end of this year, or a month before the end of the year, or 2 months before the end of the year, I'm gonna really like apply for internship for Node, and while still expanding other fields like Go, and then something DevOps type shit, or even Python. Like I want to like, I know quantity is not greater than depth, but this is what I want to do. So this is like my as you can see, it's been like a really a month since I learned Node, bruh. And so this is it. This is like my diary type shit. And then okay, this is really what I want to do, and really want to post this, because like at the end of the day, like 1 year, 2 years, if I really make it, this is like a fucking century. sanctuary, what the fuck, um, holy place sanctuary or something, for like me, and if a person stumble on it, like he will probably think I'm weird, but I think it will be genuinely impressive, because like what stuff I'm doing, like stuff like doing like clamped up everything. Like I started with Node in a month, like a month or two, and going to go, and you know the progression on this, like you know that, and this is what I want to do, bruh. So I really want that green card, by the way, and so I want to learn job oriented type shit. So like in real companies, that came to my understanding that Node Express wasn't it, and I know people get, but too lucky or too skilled, mm, perhaps. So talking a lot of shit. So let's let's do this, bro. Bro, which episode was I in? Here, and still 12. Okay.
Well, according to the Go website, Go is a fast, statically typed.
Bro, this is not the course, bro. Wait the fuck up, bro. I thought I was like, what the fuck? This is not really the course I chose. Oh fuck. Here is one. Here is that. Fucking hell, I really forgot about that for a second while like yapping all that shit. 2 years, it's okay.
Hello everyone, welcome to the first lesson in our Golang core series. In this lesson, I'm going to do a short introduction on Go. Then we will move on to installing Go on your system and then writing our first Go program. Golang, or just known as Go, was designed at Google by a team led by Robert Kreismer, Rob Pike, and Ken Thompson. Rob Pike and Ken Thompson are the same people who were actively involved with the development of C language and the Unix operating system back in the day at Bell Labs. Go is very similar to C synthetically, but it has many more features than C, especially memory safety and garbage collection.
Okay.
It takes inspiration from C, but it takes concepts from a lot of different languages. One of the example is using of channels for Go routine communication, which is taken from the language CSP. Don't worry too much about Go routines. We will learn about Go routines more in more advanced lessons. The main goal of Go was to have a programming language that is highly efficient, especially for multi-core processing. Since nowadays machines have multiple processors, Google wanted to develop a language that's really suitable for multi-core processing, network programming, and cloud computing. Actually, one of the most widely used application of Go is Kubernetes containers. It's also used to write many microservices nowadays. It's because it's easy to work with. The learning curve is not very steep, and the Go program can be compiled into a binary that can be distributed to different operating system or different machines, and it will run out of the box, and you don't need any other dependencies to run it. For example, think about Java. If you want to run a Java program, you need to have JVM or Java Virtual Machine installed on your system. Think about Python. If you want to run Python script, you would need to have Python installed on your machine. But for Go, you don't need anything. You can just create a binary and you can run on any system or platform you want. Next, we move on to installing Go. This website, I will paste the link in the description. You can download Go installer for your
Using Mac,
operating
bro.
system,
This is gonna
and
be
you just
kinda-
need to follow the instructions on the website and through the installer. Once you have it installed, you can run Go version, and it will give you the version of Go install. Like you can see in the screenshot here, I have 1.20.5 installed on Darwin.
Okay, I got it installed. I need to open that.
Darwin, which is code name for the Mac operating system. AMD6 is the architecture of the processor it's installed on. We will also write our first program in this lesson. I'm for IDE or integrated development environment. I'm going to use VS Code. VS Code is free of cost. There are other paid IDEs like Golang. If you like, you can install that too. But for our course, we are going to use VS Code with the Go extension. The first program we are going to write is just a simple program printing hello world.
Wait the fuck up. I'm really like keen in this stuff. Like
4 years ago, I couldn't even tell you what a Go routine was. Today, I'm shipping production-grade systems that scale to millions of requests all using Go. If you're new to my channel, my name is Melky. I'm a senior machine learning engineer over at Twitch. In this video, I'll relate all the checkpoints that took me from copy-pasting snippets of code to writing idiomatic test-driven Go, so you can compress years of trial and error into this single watch. So the first thing is, why did I even learn Go? And the simple answer is, in 2021, I was hired at Twitch as a junior engineer. And prior to this, I was just kind of a simple Python script kiddie working for a machine learning startup, and I had no prior experience to Go at all. So I basically had no other option but to learn Go and get go with it if I want to keep my new job. And at the time, the kind of salary that Twitch was offering was really life-changing. So it really forced me to really understand and get good with the language. As I wrote more Go, I started to get used to pointers, static typing, and all that, but I still didn't feel like I was writing proper Go. I wasn't getting any better at it. It felt kind of dry, that I didn't like it, and I really just wanted to understand like the philosophy and the approach of Go because I was writing it so much, and it just didn't feel like it was coming naturally to me. And this all changed when I came across Effective Go, an article that I talked about numerous times on this channel and over on my stream. And it comes from the official go.dev, the official documentation. And when I read this, it kind of snapped everything together for me. A straightforward translation of a C++ or Java program into Go is unlikely to produce a satisfactory result. Java programs are written in Java, not Go. On the other hand, thinking about the problem from a Go perspective could produce a successful but quite different program. In other words, to write Go well, it's important to understand its properties and idioms. It's also important to know the established conventions for programming in Go, such as naming, formatting, program construction, and so on, so that programs you write will be easy for other Go programmers to understand. And it kind of tops it off here with this document gives tips for writing clear idiomatic Go code. It augments the language specification, the tour of Go, and how to write Go code, all of which you should read first. But even after reading all of that, I came to the conclusion that reading only does so much. I mean, I could continue reading all the textbooks and watching all these videos, but I still had to put everything now I learned into practice, and the best way to do that is to actually code. These are just some of the things I found that helped me kind of get better at writing Go code. And the first one is simple to complex HTTP service for my web backend. So basically, I was able to write a front end using React, and I had my separation of concerns with my entire backend written in Go, and basically the only time they would communicate would be through the wire, through HTTP calls, GET requests, POST requests, upsert requests, anything like that. And so you can start with simple, which is kind of getting like a hello world, health checks, kind of doing a simple CRUD app, and you can really evolve that into something much more complex, like using auth systems or different protected routes, implementing your own middleware, using the context package to help you inject middleware-like properties. And so you can really take the concept of writing a CRUD app on your backend and really make it as complex as you need it to be. The next things I really got into were CLI tools, because you notice a lot of really popular GitHub libraries in Go are for the CLI, and like Cobra or Bubble Tea, anything made by Charm. And so I wrote Go Blueprint kind of after becoming more seasoned Go developer. But before that, I had another project that I called RAG, which was React AWS in Go. And it was basically like this very simple version of an SST deployment where it uses a Lambda with a Go runtime and a React front end, so you can deploy things for a production scale service. And so that helped me understand how to pass different flags, how to pass different states across my application through the CLI all the way up to the cloud using AWS. The third one was gRPC. You'll notice that you kind of hit this plateau with writing backends for HTTP services in Go. And so I eventually moved into this microservice architecture. And sometimes with microservices, you really rarely do a client interacting with your microservice. And most of the time, you'll have a microservice communicating with another microservice. And so that introduced me to gRPC protocol and allowed me to explore different ways of writing different systems that now interact with gRPC between different microservices. And it changed my thinking from how a user or a client would send down a payload to a microservice communicating with another microservice passing down payloads. And the last one was just simply writing pipeline jobs and scripts using Go. The previous three got me to the point of using Go that I was getting fast or writing pretty cheap, quick scripts using Go from Python, which was a language I used before for scripting. But now if I had to do something like go through a DynamoDB database and kind of remove corrupted rows of data, I could quickly do that using Go and even faster than Python. So just using it as my go-to obviously made me better at writing it. With all that being said, I still think there's great resources that exist that will make you a better Go developer. Some of these have existed for a long time, and some of these are brand new. However, I still think if you get around to them, whether they're a textbook, course, or a video, they'll make you a better developer. And one of those is Let's Go Further by Alex Edwards. So this is really the go-to textbook on writing a Go backend for web applications. I read this 3-4 years ago, and it was so informative that I still use some of the principles from that book today. The second category of resourcing will go under testing. Writing tests with Go is actually very easy and pretty rewarding. And one of the good resources for that is Learn Go with Tests. It's an online textbook that teaches you everything about testing with Go, and it also just teaches you about different principles of the Go programming language. And another really good textbook I recommend for specifically learning how to write proper tests in Go is Writing and Interpreting Go. You also learn a lot of cool stuff from this book by Thorsten Ball, but I also think that this does a really good job of test-driven development with the Go programming language. And another really good textbook I came across recently is 100 Go Mistakes and How to Avoid Them. This is a really good kind of general overview of things to use and not use with Go. I love how it's so clean. There's actually the source code here for the community that the author made public, and it's a really good resource on just quick kind of tidbits and understanding proper ways to write the Go programming language. And I'm going to plug my own course here, the complete course for building backend web apps with Go by Frontend Masters. This is a app course I wrote that took everything I learned from the previous resources, plus my time at Twitch, plus all the open source projects I created into one course that spans about 8 hours and just a couple of minutes, and it shows you all the different aspects of writing a Go application, from the data layer, the API routes, testing, authentication, middleware, and a bunch more, especially on how to structure your Go project. So with all that being said, all of those aspects help me be a bunch more, especially on how to identify things I was struggling with, what I happen to have become. And I'll see you guys in the next one. Peace.
I'm sorry.
I vibed so hard and got so far, but in the end, I still can't merge the fucking PR. Thanks, Randall. But we're gonna look at Go, okay? Go has. How much do you want to bet that I'm gonna disagree with this video? What do you think is like the likelihood that I disagree with it? And what are the good parts? None. Okay, you'll shut your dirty mouth. There's plenty of good parts to Go, okay? But let's find out. What are the bad parts? I swear to all that is nice and pretty in my life, if I hear one if or does not equal nil, I'm gonna just jump kick, throat chop this guy. Same time, okay? Very hard to do, especially since a lot of stretching goes on in that move.
Go has a lot going for it.
Okay.
It is developed by some of the most prolific software developers in the world. It constantly ranks high in various developer.
By the way, out of all people on this list, it's like, I definitely know this guy. I definitely know this guy. Who's this guy?
I learned the Go programming language, and here are my thoughts. People love Go for its concurrency, performance, the strong community, but I was really intrigued by its error handling. So I built a backend for this TL draw app that I was creating. Now first, here's why I disliked. Error handling was a little bit too verbose. I 100% understand why they did it this way, but for me, it just caused a lot of readability issues. Often, I just felt like I was missing a lot of packages. I mean, I come from Python and JavaScript, so they just spoil you with everything. But all in all, here's what I really liked. The error handling. I know I just kind of complained about it, but there's been so many times where it just saved me. Kind of like works like a debugger too, because you don't have to write those print statements. Go's minimal and slim standard library, it just makes me a better pro.
Here. Let's see. I have a place right here. Nice. Go, a statically compiled high-level programming language created by Google in 2007. It is simple, efficient. It has blazingly fast compile time. It has garbage collector, great concurrency model. Screw your OOP. Has best package manager. If error doesn't equals nil is a feature. And it's the language I have no opinion on because I'm still learning it. Our note here. React.
Let's go. Let's go. I actually really like that. No, I love that. By the way, I will have to say that people overestimate the if error equals nil. By the way, just for fun. Okay, I know this is not a stream of that, but you'll notice that I don't have like a ton of error equals nil, right? I mean, this error check is my own personal error check, but like you notice that you don't see a lot of it, and the reason why is that anytime you're doing code, there's not a lot of if error equals nil. But anytime you're interacting with something that's async or requesting from another service, something that is...
The tech community. On top of that, it enjoys some of the best publicity thanks to the large companies and...
If Go is bad, does that mean that Come is good?
I got to turn off TTS. That's what that's what I got to do right now. I got to turn off TTS immediately.
Successful projects who are actively using it.
Is that Netflix, by the way? Is that Netflix, by the way? This shirt is literally like 12 years old. All right, anyways.
Recently, for instance, the TypeScript team announced that they're porting their compiler and toolsets to Go in an attempt to speed up performance.
Weird. It's kind of weird that TypeScript team would choose Go. I mean, I thought everyone chose Rust, but by the way, Rust is actually a pretty good language when it comes to compilers. Like, there's a lot of benefits, obviously, to use Rust. It's pretty dang quick. But geez, why? Why would you use Go? Oh, wait, are you telling me that it's easy to make things in Go? Oh, is that why?
Performance and simplify their build pipeline. That's no small endorsement. When a language created by Microsoft engineers starts leaning on Go to improve its tooling, and the resulting performance is magnitudes better than before, Go's doing something right.
Can I also just interject for a second? The fact that it's 2025 and the TypeScript team at Microsoft is finally writing their compiler or their transpiler, whatever the hell you call this thing, from TypeScript into a language that is not horrifyingly slow like this activity is shocking. It's been around for like 12 years, and TS Server just crashes constantly. Like, the actual primary function of TS Server is to use all your memory and then crash. I am just shocked it took this long to be like, we should just like fix this, huh? Like, it'd be a good idea. We just fixing this.
But despite all Go's success, it's not all sunshine and rainbows. It might sound surprising, but while Go is an amazing language, it also has its bad parts. And I think everybody who plans to learn or use Go in their next project should be aware of this caveat.
You know the worst part about Go is that channels feel really nice to use, and then you overuse them. There's like almost very few uses of channels you need. Just pretty much don't use them unless it's like really, really needed, and then all of a sudden it's easy.
Yes. For a bit of context, I'm a software developer with more than 15 years of experience, and during this time I worked mainly with Java, Kotlin, and TypeScript. For the past year, I decided to transition to Go in all my personal projects for the reasons we all know by now. Go is simple, fast, efficient, it has great tooling, and it is a breeze to compile and deploy. But after actually writing Go for a while, I realized things are a lot more nuanced, and not everything lives up to the hype.
Okay.
Let me explain. This doesn't mean Go is a bad language. However, we need to paint the full picture because just like Go has some amazing parts, it also has sharp edges that you only discover once you spend real time building something non-trivial with it. The design decision.
I do love that there was recently this like up in arms, everybody's super angry at Go because they finally decided after 12 years to fix the fact that a for loop was referencing or was keeping the same variable in the loop over and over again. In like 1.21, they finally were like, all right guys, fine. When you for loop now, we'll stop doing that. We'll create copies of the object so you don't actually mutate everything and you don't have references that end up pointing to whatever the last variable was. Right? It's insane that it took that long.
That make Go such a powerful tool.
Hours of my life, like, and then when you finally make the switch over, you also lose hours of just doing stupid stuff. It's hilarious.
Especially if you already have a standard and a set of expectations based on working with other languages. So here are 5 things you really need to know before switching to Go. It was surprising to find out that based on some Google searches, apparently I'm not the only one noticing these things. One of Go's biggest selling points is its simplicity. To be fair, it really does look simple on the surface. There are few keywords, the syntax is minimal, and the official docs go out of their way to keep the language easy to learn. But once you go beyond the tutorial...
But... That's pretty good. I don't know, maybe I'm a child. Maybe I'm a child.
You start realizing that Go's simplicity is mostly skin deep, and it often comes at the cost of expressiveness. It's the little things which...
Isn't that like literally the trade-off? Isn't the trade-off of a language that's super simple is that you're not meant to express complex states? I mean, I don't think that this is a negative thing. I think this is like an actual design principle. Hey, we're gonna just make you use if statements for the most part. That was like the goal. Was like, hey.
Bro, I'm getting way too much hiccup. So I'm gonna like pause it and watch this video, and when I'm learning Go, I'm gonna record it. My hiccups are not going, so mute the mic and let's go study.
To the console. So without wasting any time, simple program printing hello world to the console. So without wasting any time, let's go to the code. So here you can see I have opened the website that I gave the link to, and in here you can download the Go installer for your operating system. It will auto detect your operating system and provide you the relevant installer for Go, for Linux and for Windows. Once you have it, you need to follow these instructions to make sure that Go has been installed. For Linux, these are the instructions. For Mac, you can find these instructions, and for Windows, you can find these instructions. Again, once you have it installed, you can just run Go version to make sure Go has been installed. Next, let us look at VS Code. So VS Code will install from the internet. That you will install from the internet if you install any Golang tools. It will be installed here. All the standard libs are installed in this path, development tools out of the box. So you can just run go help and it will give you all the commands. I will just enlarge this window so that you can see it here. As you can see, these are all the commands available. Build, FMT, these are some of the widely used commands. We will go discuss about them in the following lessons. Okay, so let's now create our first Go program. I'm going to create a file named main.go. Go is the extension for Go files. Every Go program needs to have a main.go file, and inside it, it has to have a package main. Inside package main, it needs to have a function name called main. Every Go program needs to have it. This is because this is the entry point, it has to have a package main. Inside package main, it needs to have a function name called main. Every Go program needs to have it. This is because this is the entry point for any Go program. Think about it. If you are starting a car, inside the car engine, there are many components like the driving belt or the piston or the fuel injectors, all those things. They all work together to make your car run. But to start it, you need to first turn on the ignition and start the car, right? Similar to that, in Go, we have main.go, which is the entry point for every Go program. The Go program will start from here and shut down from here. I'm going to import fmt. Don't worry too much about imports and packages. fmt is a package that comes with standard library. So if you see, it will automatically import it. And I'm going to use a function imported by fmt called println. Inside println, we are going to type our string that we want to print. Okay, so you see the package hasn't been imported. Don't worry too much about packages, modules, or anything like that. In the following lessons, we will cover each one of those. So don't worry if you get confused by anything. So in the println function, I pass the string hello world. Now to run the Go program, we first need to save it. Save. Then I'm just going to run it from the command line here below. Go run main.go. So go run here is the command, and main.go is the file we want to run with go run. You can see it printed hello world. What go run does is when we say go run main.go, it will take code from main.go and compile it into a binary and save it into a temporary file from where it can run it. Once it runs the binary, it deletes it. But if you want to build a binary out of the Go code, you can do so with the build command. So go build, it deletes it. But if you want to build a binary out of the Go code, you can do so with the build command. So go build -o hello world main.go. -o is to supply the name of binary. So we want to name our binary hello world, and I want to use the code written in me. Once we run that, you will see we have main hello world. It runs the binary, it deletes it. But if you want to build a binary out of the Go code, you can do so with the build command. So go build -o hello world main.go. -o is to supply the name of binary. So we want to name our binary hello world, and I want to use the code written in main.go to create that binary. Once we run that, you will see we have an executable called, or a binary called hello world. If you want to run it, you can just type hello world, and here you can see hello world was printed. Now binary again is the code. Or a language that the computer understands. That's why we call it binary, because it's one bunch of ones and zeros. And in those ones and zeros are instructions to the CPU that our compiler provides for our program to be executed. Don't worry too much about the words used here, like compiler or binary code. Slowly, with time, you will get there. That's it for our first coding session. Thanks for watching. I hope you enjoyed the lesson. Again, if you have any question, just reach out to our Hello everyone. Welcome to the second lesson in the Golang course. In this lesson, I will introduce you to primitive or the basic data types in Go. Before we start, let us discuss what are data types and why we need them. A data type is just a categorization of data. Think about why we write programs. Almost all the programs we write are to assist humans, right? In our daily life, we use different kind of data, from using numbers for monetary transactions like sending money or receiving money, to using strings to send text to our friends. Our brains can comprehend what the properties of each data types are and how to deal with them, because we learned it through education in our school, right? So number multiplication, strings, how to write something, how alphabets can be put together to be considered string, right? A computer program has properties associated with data types, but it needs to know what data types we are using when we write a program. So to write a program that the computer can understand and to make it work, we use data types. In this lesson, we will cover what primitive or basic data types are, the primitive data types in Go, and then finally look at a small coding lesson to see how the data types are used. So let's begin. What are primitive data types? Go is a statically and strongly typed language. Statically typed language means that every variable or constant that we use in Go needs to have an associated type with it at compile time. So the compiler needs to know what type of variable or constant is when we are using it at compile time. Strongly typed means that once a type is associated with a variable, it cannot be changed from one type of variable or constant is when we are using it at compile time. Strongly typed means that once a type is associated with a variable, it cannot be changed from one type to another. You can cast it, but you cannot change the type of a variable or constant. For example, if you know a little bit of JavaScript, it's a dynamic type language. A variable can change its types throughout the life of the program, but this is not the case with Golang. Each variable has to have one type, and that type can never change. This is very helpful in reducing the number of bugs in our program. Primitive data type or the basic data types, as the name suggests, are the starter data types provided by the language. Composite data types, on the other hand, are made up from primitive data types. An example would be an integer in a Go is a primitive or the basic data type, but an array of integer is a composite data type. So array of integer is made up of int values. Again, don't worry too much about what arrays are. We will cover them in the future lessons. The basic or primitive data types of Go can be categorized into three categories. We will dedicate lessons to each of the category to study them in detail. This is just an introduction. A Boolean data type is used to represent two states and two only. It can either be false or it can either be true. We usually use it when we need to make a decision to select one of the two options. So if the Boolean is true, we select one option. If not true, then we select the other one. Strings are used for text encode, like displaying a message to the user. In our first program that we wrote, we actually used a string hello world to print it to the terminal. There can be multiple or single line strings. We will look again at it in depth in the dedicated lesson for strings. Go actually supports Unicode strings, so this is a little different from if you are coming from languages such as C or C++. We will understand the differences again in the dedicated lesson. Number category is quite a big category, and it includes integers or int, floats, or floating point numbers and complex numbers. There's also a concept of zero value in Go. Again, when we go into the coding lesson, we will look at the zero values. So without wasting any time, let's go into the coding session. So as I told you before, I'm going to give you a demo of different data types in Go. We will just go about the basic data types, and that too is limited to small set. In the following lessons, we will cover each data type in depth. So let's start with creating a main.go file here. And as we did with the last program, let's create package main, which is again an entry point, func main. So let's start by first creating a string variable, var my string. So as you can see, var stands for variable. I'm telling the Go compiler that it's a variable. Don't worry about variables again. We will cover them in a different lesson in depth. MyString is the name of the variable, and string here is the data type of this MyString variable. We haven't assigned any value to it yet, so Go has a concept of zero value. For string, zero value is an empty string, right? So if I do fmt.println my string and then go run main.go, you will see nothing is printed on the command line. Now let's assign my string a value. My string is equal welcome to code and learn. Okay, so now my string has a value. So let's try and print it again. Let's run our program again. Go run main.go. You can see it printed an empty line and then our new line, or the new string that we assign the value to. Now let's create another variable of type int, var my int. Again, here I'm telling the compiler that my int is a variable of type int. So you can see that I'm getting an error which says that my int is declared but not used. If you try to run a program where we have a variable that's declared but not used, we will get a compile time error. Go run main.go. So you can see it's telling you on line 12 in our code, my int is declared but not used. So I have to use it. And this prevents a lot of errors. Again, getting back to the topic, the data type of my int is int. Number values will have a zero value of 0. So since I have not assigned a value to it myself, if you try to use it, it will print 0. Zero value for int for number types is 0. Okay, so I do fmt println my int. Now you can see the compiler error has gone away since we are using it, and once I type go run main.go, you can see it prints 0. I can again assign a value to it, my int 10, and then do a println again after assigning a value. Again, we will run go run main.go, and you can see first when the value is not assigned, it prints 0, and when I assign a value, it prints 10. Now let's see the next category, which is pool, var my pool of type bool. Again, I'm telling the compiler that my bool is of type variable and the data type is bool. The zero value for bool is false. So go, and you can see first when the value is not assigned, it prints 0, and when I assign a value, it prints 10. Now let's see the next category, which is pool, var my pool of type bool. Again, I'm telling the compiler that my bool is of type variable and the data type is bool. The zero value for bool is false. So as I told you in the lecture, a bool can either be true or it can either be false. And those are the only two values a bool can have. And the zero value for bool is false. So if I try to use it, fmt print line my bool, you will see we get false printed to the command line. Let's change the value to true and then print my bool. Now you should see the value true printed. So this is the zero value before I updated it to true, and this is the value we updated it to. Now as I said, my bool, which is a bool variable, can only have true or false value, and since Go is strongly typed, I cannot assign an int value or a string value. You can see that there is an error. Similar is the case with other values. So if I do my int and try to assign it a string, the compiler will complain about it. My string and I try to assign 10, it will complain, but if I try to assign a different value, it is fine. So that's the basic introduction to data types in Go. In the next lessons, we will cover number data types in depth. So don't worry again if you don't understand anything from this lesson. Slowly, if you can code along, that would be great, and slowly you will understand it. Thanks for watching this lesson. If you have any question, just Hello everyone, welcome to the third lesson of our Golang course. In this lesson, we are going to learn more about the int or the integer data type that we introduced in the previous lesson. First, we are going to discuss the int data type. Then we will move on to another integer data type called the unsigned int. In the third section, we are going to discuss some other related data types. And in the fourth section, we will jump on to the code. The data type int can be used to store positive or negative integer values without fractions. Some examples are 100, minus 2, 3, 4, 500, etc. If you try to store a fraction in an int data type, the fraction part will be dropped. The int data type has values. We are going to discuss in this lesson. We are going to learn more about the int or the integer data type that we introduced in the previous lesson. First, we are going to discuss the int data type. Then we will move on to another integer data type called the unsigned int. In the third section, we are going to discuss some other related data types. And in the fourth section, we will jump on to the code. The data type int can be used to store positive or negative integer values without fractions. Some examples are 100, three, 4, 500, etc. If you try to store a fraction in an int data type, the fraction part will be dropped. The int data type has different variants like int 8, int 16, int 32, etc. These variants have different sizes in memory and as such have a different range of the integer values that they can store. The first bit in memory for int data type holds the sign of the value. It tells if the value is positive or negative. The rest of bits are used to store the value itself. So let us look at all the integer data types. First we have int8 integer data type. Int8 data type uses 1 byte or 8 bits in memory to store integer values. Again, since the first bit is used to store the sign of the value, the available bits to store the actual values are 7. As such, the range of value it can store is between and inclusive is equal to minus 128 to 127 positive, which is approximately equal to 2 raised to power 7. If you consider 0 a positive value, 2 raised to power 7 is 128. There you have it. You can store 128 positive values and 17 to 127 positive, which is approximately equal to 2 raised to power 7 to 127, and inclusive is equal to minus 128 to 127 positive, which is approximately equal to 2 raised to power 7. If you consider 0 a positive value, 2 raised to power 7 is 128. There you have it. You can store 128 positive values and 128 negative values. Similar to int8, there is int16, which uses 16 bits in memory to store integer values along with their sign. Again, the first bit is 16 bits in memory to store integer values along with their sign. Again, the first bit is used to store the sign of the integer value, and the rest of the 15 bits in memory are used to store the value of the integer. The range of value that you can store in an int16 data type is between minus 32768 to positive 32767. Again, if you see 2 raised to power 15, which is the available bits, we have 15 bits is equal to 32768. So if you consider 0 a positive value, you can see that you can store 32768 positive and 32768 negative values in an int16 data type. Similar to int8, int16, we have int32 and int64. By now you probably understand that number in the suffix of the data type tells you how many bits are used in memory to store the numeric value. Int32 uses 31 bits of memory to store the value and 1 bit of memory to store the sign of the value that it's storing. The range of values that it can store is greater than both int8 and int16 since it has more bits to store the value. Similarly, int64 uses 63 bits to store the value and 1 bit to store the sign of the value stored. The range of values it can store is greatest among the signed integer data types. Next, let us have a look at another integer data type called unsigned int. As the name goes, you can only store positive values in this data type. Since this too is an integer data type, the fraction will be dropped if you try to store a value with fractions. Similar to our int data type, there are different variables of unsigned int data types. For example, unsigned int 8, unsigned int 16, unsigned int 32, etc. Again, similar to the int data type variant, each of these types have different sizes in memory, as such different range of values that they can store. Since the integer value stores are all positive, all bits in the memory are used to store the value. As such, it has a large range and it can store large positive numbers. First up, we have unsigned int 8. The unsigned int 8 data type uses 8 bits to store the values. It can store value from 0 to 255 inclusive, which is equal to 2 raised to power 8. Actually, 2 raised to power 8 is 256, but 0 is considered a positive value, so in total you can store 256 values. Similarly, we have unsigned int 16, unsigned int 32, unsigned int 64, which use 16, 32, and 64 bits of memory to store the values. The range is in the column on the right. By now, you should get a hang of telling what an integer data type in memory by looking at the name itself. Let us look at some other data types related to int and unsigned int. First up is byte data type. Byte is an alias for unsigned int 8, which makes sense since 8 bits of memory constitute 1 byte. The byte data type is usually used to represent raw data. Next, we have the rune data type. A rune is an alias for int32. The rune data type is related to strings. We will cover that in the future lesson. For now, just remember a rune is an alias for int32. The last ones are unsigned int and int. So you may ask, what is the size of int and unsigned int, as there is no suffix number attached to the data type name. The size of these two types is actually dependent on the architecture of the machine. For example, if your program is running on a 32-bit computer, the size of unsigned int and int in memory will be 32 bits. On a 64-bit architecture, it will be 64 bits in memory. Usually you would use int and unsigned int whenever required instead of the size specific integer data type, which should fulfill all your programming needs, unless your program is going to run on a varying architecture machine. For example, if you are writing a program that will run on laptops, embedded machine, IoT devices, etc., you should explicitly specify the int and unsigned int value that is enough to accommodate the number you are storing. If the value you are storing in a given data type surpasses the maximum or minimum value it can store, it will lead to an overflow error. Let's practice these data types with code now. As I told you before, we are going to explore the integer data type and all the related data types to it. So let's first create the main.go file. Inside main.go file, we will create package main, and inside package main, we will create func main. First, I'm going to create a variable of type unsigned int. Var small positive value is of type unsigned int 8. So I've declared the variable. Now I can assign a value to it. fmt dot println small positive value. If I run the program now, go run main.go, you will see 10 printed to the console. Now, since small positive value is of type unsigned int 8, it can only store minimum or a limited value between the range of 0 and 255. It cannot save negative integers. So if I try to save a negative value, we will get an error. You will see that we have an overflow error. The editor here is smart enough to let us know that this will result in an overflow error. This will also cause an overflow error if I use a value that exceeds the maximum limit. So if I use 260, you will see that there's an error. So next we are going to create a variable of type int 8. Var small positive negative int of type int 8. Small positive negative int can be assigned value -10. It doesn't complain because if you remember from the lecture, it can go up to -128. Alright, but if I try to exceed the value, it will complain again. So let's print out the values. Go run main.go. The other integer types like unsigned int 16, unsigned int 32, unsigned int 64 are very similar to unsigned int 8. Only difference is the range of values that they can store. Similarly, int 16, int 32, int 64 are very similar to the int 8 value that we used. The only difference is the range of values that it can store. If I create a variable of type int, as you remember from the lecture, it will be dependent on the architecture. The size of this variable will be dependent on the architecture and the values we can store on it. So I can store a really large value and it should be fine. Now if I want to save the unsigned int value into myInt, which is of type int, myInt is equal to small positive negative integer, you can see it's converting it to int, even though this is int 8, which is a int. If I want Now if I want to save the unsigned int value into myInt, which is of type int, myInt is equal to small positive negative integer, you can see it's converting it to int. Even though this is int 8, which is a type of int, it still needs to convert it to int. That's because Go is strongly typed and int 8 are considered different types. I can also do myInt and do Now if I want to save the unsigned int value into myInt, which is of type int, myInt is equal to small positive negative integer, you can see it's converting it to int. Even though this is int 8, which is a type of int, it still needs to convert it to int. That's because Go is strongly typed and int 8 are considered different types. I can also do myInt and do small positive value only, which you remember is unsigned int 8. Again, it will be typecasted into int. To typecast a value, you type the type on the left side or the type you are converting into, and then brackets inside the value you are typecasting it, like we did above. That's how we do typecasting. Now, typecasting can only be done for types that can be converted. So I can convert unsigned int into int. But if I try to convert a string value or typecast a string value into int value, the compiler won't do it. So only like types can be converted into each other. Let's get rid of this line. Next, into int. But if I try to convert a string value or typecast a string value into int value, the compiler won't do it. So only like types can be converted into each other. Let's get rid of this line. Next, we will look into the byte and the rune types. Var my byte is of type byte, and I can assign the value on the same line. fmt println my byte. So here I am assigning it a value of uppercase A, which is in the ASCII range, or it can be stored in a byte. So when I print it, you will see that the integer value for my byte is printed. Go run main.go. You see here 65 is the ASCII code or the integer value for A or uppercase A. If I assign my byte value .go, you will see that the integer value for my byte is printed. Go run main.go. You see here the ASCII code or the integer value for A or uppercase A. If I try to assign my byte values that are bigger than a byte can hold, the compiler or the IntelliSense here will start complaining. It again leads to a compilation error. Byte is mainly used to represent raw data and also to distinguish between unsigned int 8 and byte, since byte is an alias for unsigned int 8. Cool. Now let's move on to our rune var my rune of type rune is equal to uppercase P. Rune is an alias for int 32. It can be divided into 4 bytes. Rune is closely related to strings because rune is basically used to represent a Unicode code point. I will talk more about this in the strings lesson, but strings in Go support Unicode, and Go uses UTF-8 to encode that Unicode. And when you encode a Unicode character using UTF-8 encoding, each character can take up to 1 to 4 bytes. So that makes sense why 8 and byte, since byte is an alias for unsigned int 8. Cool. Now let's move on to our rune var my rune of type rune is equal to uppercase P. Rune is an alias for int 32. It can be divided into 4 bytes. Rune is closely related to strings because rune is basically used to represent a Unicode code point. I will talk more about this in the strings lesson, but strings in Go support Unicode, and Go uses UTF-8 to encode that Unicode. And when you encode a Unicode character using UTF-8 encoding, each character can take up to 1 to 4 bytes. So that makes sense why we are using in 32, which is total size of 4 bytes. Again, you will see that the integer value will be printed for uppercase P66 being printed. So now if I try to assign rune or my rune a emoji like this, that should work fine as well. I can do fmt println. And that's the integer value for the byte data stored in my rune. If I add a space in front of the emoji, you will see that the IntelliSense is complaining about it. That's because it's overflowing the value that can be stored in my rune, because there are 2 characters, and if you remember correctly, 1 Unicode character can take up to 1 to 4 bytes. So we cannot store 2 Unicode characters that can take up to 1 to 8 bytes in one rune. That's it for our coding session in our int data types. I hope you enjoyed it. I haven't gone over all the int types, but that's because I not go. The other integer types like unsigned int 16, unsigned int 32, unsigned int 64 are very similar to unsigned int 8. only define our var small positive negative int of type int 8, small positive negative int can be assigned value -10. It doesn't complain because if you remember from the lecture, it can go up to minus value into int value. The compiler won't do it. So only like types can be converted into each other. Let's get rid of this line. Next, we will look into the byte and the rune types. Var my byte is of type byte, and I can assign the value on the same line. FMT println my byte. So here I am assigning it a value of uppercase A, which is in the ASCII range, or it can be stored in a byte. So when I print it, you will see that the integer value for my byte is printed. Go run main.go. You see here 65 is the ASCII code or the integer value for A or uppercase A. If I try to assign my byte values that are bigger than a byte can hold, the compiler or the IntelliSense here will start complaining. It again leads to a compilation error. Byte is mainly used to represent raw data and also to distinguish between unsigned int 8 and byte, since byte is an alias for unsigned int 8. Cool. Now let's move on to our rune var.
Alright guys, in this video, we are going to learn all
is equal to uppercase P. Rune is an alias for int32. It can be divided into 4 bytes. Rune is closely related to strings because rune is basically used to represent a Unicode code point. I will talk more about this in the strings lesson, but strings in Go support Unicode. And Go uses UTF-8 to encode that Unicode. And when you encode a Unicode character using UTF-8 encoding, each character can take up to 1 to 4 bytes. So that makes sense why we are using int32, which is total size of 4 bytes. Again, you will see that the integer value will be printed for uppercase P, 66 being printed. So now if I try to assign rune or my rune a emoji like this, that should work fine as well. I can do fmt println and that's the integer value for the byte data stored in my rune. If I add a space in front of the emoji, you will see that the IntelliSense is complaining about it. That's because it's overflowing the value that can be stored in my rune because there are 2 characters and few accurately, one Unicode character can take up to 1 to 4 bytes. So we can store one Unicode character can take up to 4 bytes. So we cannot store one Unicode because there are 2 characters and if you remember correctly, one Unicode character can take up to 1 to 4 bytes. So we cannot store 2 Unicode characters that can take up to 1 to 8 bytes in one rune. That's it for our coding session in our int data types. I hope you enjoyed it. I haven't gone over all the int types, but that's because I want you to practice it. Try playing around, try typecasting, try converting, and try printing the values. Try to see what you see, and try overflowing and see how much values you can store, and try playing with it. Thanks for watching this video.
Okay, this is the ending time, boys. So package main, this is important fm for print. Okay, you can see it, bruh. There are 4 families of operating function defined by the operating system. Okay, this is func is function main like C programming main function is return variable. It's a variable name and data type. So string So my string is always a string, it cannot be converted to another. But there's typecasting of like um um okay, typecasting like this, like my int is 16 and my on sign is int, though they are the same, bruh. So it just converted into int 16 of this shit to save in that int 16 fm the print line. Okay, I got you. So that was today, brother. Okay, it's like 1 a.m. in the morning. So good day. Thanks if anybody is watching. So I'm gonna make it even if I have to do anything, bro. So but I'm gonna make a sick ass software developer, bro. Um, Believe it, bro. I grew up I watched not as a kid. So believe it, bro. Bye.